Hi everyone, this is Rachel Chung. I am here to share my SingleNeuron Simulator with you. The link to the simulator is available in the Canvas announcement, so you can feel free to click through and take a look at the simulator yourself. I wrote this a few years ago to show students how to train a single neuron to learn from 3 features with up to 16 records. In this neuron, you can adjust the bias value to increase or decrease the learning rate. We will, in a minute, go to the SingleNeuron tab and start the simulation by clicking on one of these 2 buttons. You will see a train button to feed 1 record at a time to the model for training. And then you can also hit the reset button to reset the entire model and start over. So let's go over and take a look. So the neuron is really just up here in this engine or the neuron portion. It takes input. These are input features in terms of numbers. I have put 3 features here, but of course the neuron can learn from any number of features. And then it'll produce 1 prediction. So the prediction is the predicted class. Prediction is usually written in this notation of y hat. And then we also have the actual class. The data set that we're using is below this line over here. So the rest of the model is really just the top portion. And then it's taking data records from the data table below the line. I put everything on the same sheet just so that it's easier to see. So these 3 features can be any feature, but for this example, we're using the Titanic exercise from Kaggle. So Titanic is a very famous Kaggle competition for beginners, just for people to learn about the basics of machine learning. The 3 features I included here are all zeros and ones. So they're categorical variables. The first one is called embarked, and the code of 1 means that the passenger embarked at Southampton, 0 means Queensland. Gender, 1 is for female and 0 is for male, and then price is just the price of the ticket for Titanic. 1 is expensive and 0 is not expensive or cheap. And the outcome that we're predicting here, the y variable, is 1 if the passenger survived and 0 if the passenger did not survive. Now, there are definitely a lot more features than these that we know about the actual Titanic passengers. The entire data set is available on Kaggle. Feel free to take a look. We really only extracted 3 variables from a small set of passengers. Only 16 records just to demonstrate this neuron. So you can see that these are features about these 16 passengers, and these are their survival records. So some of them lived and some of them did not survive the tragedy. All right, so using this neuron, you will see that the neuron is really just a math equation. It calculates the multiplication, the product between the features and also the weights. And then the total amount that comes out of this neuron is then converted into a 0-1 classifier using this very simple step function. So the step function is the activation function that I chose for this neuron. You can use sigmoid function. You can use the ReLU, which is what we did for the homework assignment. You can implement any function, but here I just do a very, very simple, if this neuron output is greater than 0, then I make a prediction of 1. Otherwise, I make a prediction of 0. This prediction then can be compared to, sorry, I made an editorial error. So this prediction can then be compared to the actual answer, which is included in the data set. And then we can calculate the error term. So the error is really just the difference between the 2. So you can see the equation. And by the way, I built the whole thing on Google Sheets so that it's all sort of naked and transparent. You can see all the formulas. And hopefully you'll get the notion that this neural network has a lot of jargon and a lot of terminology, but really it's just a series of numbers. And it's a series of mathematical functions that goes iteratively. So it's really looping through each record one at a time and to learn from this data set over time. You will look at the error term, and this error term can be recorded over here. So this, I stopped this training at trial 4 previously. So you can see that trial 4 actually made a correct prediction, meaning that the prediction, the y hat is the same as y. And so if you do a difference between the two, you get a value of 0. When the prediction is different from the actual answer, then you will actually get an error term that's greater than 0. So using this error term, that we can decide how much adjustment we want to change to the weights. The weights are over here. And then we'll go, once the weights are adjusted, then we do another run of prediction using the next record and the next record and so on and so forth. And hopefully you will see that the neuron learns just like a puppy or a child. It'll start by making a lot of mistakes, but over time, the number of errors will decrease and the number of accurate predictions will go up. And eventually the neuron will learn all the patterns in this data set and start to make correct predictions all the time. So you will see this learning happening right in front of your eyes based on these very, very simple arithmetic. You know, there's nothing really fancy beyond addition, subtraction, multiplication, right? And probably not even division. It's just very simple calculations, and you can see that the pattern gets detected and learned very quickly within 16 trials. So I am going to reset this model so we can start from scratch. Okay, so what this button does is that it removed all the features, and the model starts with weights of 111 for all 3 features. And these numbers, actually, the starting weights can be anything, really. I just start with this preset. You can change these, and it may change the learning rate a little bit, but usually the weights are started at random. Okay, so we just pick some random weights. And then I'm going to start training the model. So when I click train, what it does is that it just copies these 3 values, 1, 0, 0. So the features for the first record up here so that it's easier for us to use. So these features are then multiplied by the weights, and the starting weights are just chosen by me. There's really no theoretical reason why we use 111. It's just something that I started with. Again, you can pick the weights randomly. So the neuron, what it does is it does sum of products between these feature multiplied by weight, feature multiplied by weight, feature multiplied by weight. So these are actually your input feature, input data. So your X data set is one record. And then the weights, you can think about these weights as beta values in your regression model. So these multiplied together, we get a total, okay, of 1, and then the neuron uses this very simple step function to determine the prediction. So if the value is greater than 0, then we make a prediction of 1, otherwise we make a prediction of 0. So the prediction here is 1 because the calculation is greater than 0, and this prediction then is compared to the actual survival record, which is a 0, so we actually made a mistake in the prediction. So there is an error. The error is calculated as the actual minus the predicted. So we get a -1, which means that we made some mistake. So what we do is the learning process. It's actually very similar to how we learn. So you may, when you are new to a domain, some sort of task that you're learning from scratch, you may have no idea what to do. So you start with some random weights, and you will try to guess something, and you probably guess completely wrong. But what you can do is, if you have the correct answer, you can compare your guess to the correct answer, measure how different you are, and then we can start to make some changes to the weights. in a direction that will help you minimize the error. So what we do is there's a bias, which is the learning rate here. 0.3, again, this is a number that we picked pretty randomly. You can have a bigger number, a smaller number that will determine if you're going to learn a little faster or slower. 0.3 is a number that we have, but basically what we do is we multiply this number with the feature value, so the X feature values from here, and the error. So we do this multiplication, and then we will get these 3 deltas. These are deltas that we will use to adjust the weights the next round. Okay, so the delta is 0.3, the first one is 0.3, the bias is 0.3 multiplied by feature of 1 for embarked, and also the error, so over here is -1. So we get a delta of -0.3. The second and third ones are zeros because the feature values are 0. So what we're going to do is next round, you're going to see a decrease of 0.3 in the first way, and the second and third weights will remain the same. And that's going to be the new set of weights that we're going to apply to the second record. So the second record will be copied over here, and then you will see a new sum of product over here. So I'm going to start training the second record now. So this is our second round of training. As you can see, the second record has been copied up here. The weights have been adjusted as I explained. Now the first one was decreased by 0.3, so we have 0.7 here. And the second and third remain as 1. So the sum of products between the features and the weights, again, is calculated over here as 1.7. And the step function is applied to convert this calculation result to a prediction of 1. But again, our actual survival record is a 0. So again, we made a mistake. So the error is -1. And again, this error is multiplied with the bias and also the features values to produce this delta, which is the change that we're going to further make to the set of weights. So this time around, both the first and the third weight, these 2 weights will be decreased by 0.3. Okay, so the next round you will see. I'm going to click the button now. So now it's our round 3, and round 3, the features is 1 when the data values are 1, 1, 0, and then the weights were adjusted as I explained, and now we have a new calculation. Again, this new calculation is greater than 0, so I'm making a prediction of 1. Again, we made a mistake, so again, we're going to continue to make adjustments to our weights. So the next round of training, okay, this time the weights were changed again, and the feature is 1, 1, 1. They were copied over here, and you produce a number that's greater than 0, and again, we make a prediction of 1. This time we actually made a correct prediction because the actual survival for this record number 4 is a 1. So we made a prediction of 1, but this one is a correct prediction. So our error is 0, which means that we're not going to adjust the weights next time because we made a correct prediction. So error is 0. That means 0 changed to the weight. So this set of weights will remain the same. However, keep in mind that the next round, we're going to have a new set of values. So these values multiplied by the weights, who knows whether the next prediction is going to be correct or not. So we're going to train again. So as you can see, the weights remain the same. The values is a new set of values. Our prediction is again a 1. However, the actual correct answer is 0. So again, we made a prediction, an error. So this error is going to be used to make additional changes to the weights. At this point, over here, we're using a pie chart to keep track of our total number of records. We have gone through 5 records and made 4 mistakes. So the error rate is actually 80%, which is really high, but you have to keep in mind that we started with 100% error rate. So the error rate has actually gone down to 80% over time. Okay, not super impressive, but we are moving in the right direction. So I'm going to keep training, and what I want you to watch is how the error rate is changing over time, right? So we went from 100% error rate now down to 80%. Do you think that this error rate will continue to go down or not? And if we want to say that the neuron is actually learning about the statistical patterns in the data set, what we expect to see is a decrease of error rate over time. So I'm going to train for the 6th round. Okay, so you see that the error rate actually went up a little bit because we produced another mistake. But we'll keep going. This time we made a correct another error. So every time we make an error, we will make some more adjustments to the weights. Okay, so again, we have pretty high error rate because we continue to make mistakes. This round, we actually made a correct prediction. So the error rate has gone down to 75%. Next round, again, it's a correct prediction. So the error rate has gone down to 66%. Another correct prediction. So as you can see that the model seemed to be stabilizing. Somehow it has started to make all these correct predictions. So it's really looking very promising. Next round is another correct prediction. So we don't change the weights and the prediction continues to be correct. So the next round, the correct answer is a 1, and we actually made a correct prediction of 1. So again, we didn't make any mistake. And so as you can see, this set of weights have stabilized. That seemed to be an optimal set of weights that continues to produce correct predictions. So again, it's the actual class is 0, and we correctly made a prediction of 0. So again, we produce another accurate prediction. Next round, correct prediction. Next round, correct prediction. But it's been a series of 0. So I'm curious about whether this number 1 is going to be a correct prediction. Right, so does the machine actually turn around and make a correct prediction of 1 this time around? So this is our last round. And for this 1, the survival, we actually correctly predicted 1. So you can see at this point, the error rate is 37.5. We went from 100% error now down to only 37% error rate. So pretty impressive. And as you can see that the neuron was able to learn everything about this data set within a matter of a few records. I think starting about 8, over here, it took about 7 or 8 rounds for the machine to settle, the neuron to settle on an optimal set of weights that always produces correct predictions. And so we can declare that this neuron has successfully learned the pattern in this very limited set of Titanic data. And we can now use these ways to build, this is our model. And we can use this model to make future predictions about other passengers and their survival, whether they're going to survive or not. So, for example, Rose from the movie, it's a fake character, right? On the ship, she did not actually go on the ship, so we don't actually have her survival records. But what we can do is we can plug in the features about Rose and see if the the neuron actually make a correct prediction about her survival or not, given her records. So hopefully this very small simulator of a single neuron gives you the idea of how neural networks work. No matter how complex the neural networks work, it's really based on these very simple ideas. You have input data, you have weights that get adjusted based on feedback, right? So there's a learning loop that goes through over time. And that you keep adjusting the weights based on the feedback from these errors. So these errors are very important. They are your teachers, and they give the neuron feedback about the direction and magnitude of changes that we should apply to the weights. So you keep adjusting based on the inputs until you have until the performance has stabilized or optimized. If you're curious about the code is written in JavaScript because that's the language behind the Google Sheets. You can write an app script, very simple. I wrote this neuron just by creating a few functions. The function of initialize is for the reset button, and the function of train model is for the train button. And it just calls a few very simple copy and pasting functions to iterate through. And it's a very simple loop that goes through the process of updating, right? The different cells and the calculations. And hopefully you see that it's really the neural network, no matter how much hype there is, it's really just a series of mathematical functions that get updated over time. All right, so I hope you enjoyed this demonstration, and good luck with this week's assignment. Feel free to contact me if you have any questions.